Good morning, everyone. How are you guys doing today? I want to thank you for joining me on this live stream on a Saturday for Saturday morning and maybe close to your afternoon, wherever you're coming from. I'm coming from San Diego, California. And in this live stream, I'm going to go through my Wi-Fi 6E lab equipment. What we're going to specifically talk about here is using my EnGenius 336 access point. I have it already plugged in. This is a 6 gigahertz access point. It's tri-band. The ECW 336. It's cloud managed. This is what I'm going to use to kind of go through some Wi-Fi 6E lab configurations, how to configure some of the features on this AP to test 6 gigahertz. Now, if you don't know, this is by EnGenius, and it's got a 5 gig capable port. Now, I do have it plugged into a switch. That switch is it's a RUCKUS ICX 7150, I believe, 7150 switch. And in that switch is an M gig capable, so it's connecting at 2.5 gigs down at my switch port level. Connected to that switch is also a VMware ESXi server 7.0, and it has 2 virtual machines that I've configured to run some speed tests and also a couple of iPerf servers. That is connected via 10 gig to an Ethernet port on the ICX 7150 as well. What I really want to do is try to configure 6 gigahertz here and do some throughput tests. So I have some other tools in my Wi-Fi 6E lab, right? So the first thing that you need is you need a 6 gigahertz capable access point. It may be kind of difficult to see that and grab that right now, but with logistics and shipping delays and also the cost of access points, it can be difficult. If you guys can hear me pretty well, give me a thumbs up there, or let me know in the chat where you're coming from. I'm interested to know where most of you are viewing this live stream from as I get situated. I almost didn't run this live stream because I didn't have coffee, but I managed to run. Oh, and it's dripping off to the side there as I pick it up. But I managed to run and get some coffee right before this stream. So going through some of the tools that I will use in my Wi-Fi 6E lab, you definitely need a client that is capable of doing 6 gigahertz. And the key here for a lot of this is, for me, a Samsung phone. So I've got a Samsung S22 Ultra, I believe. Now, it's not the primary phone I use for my day-to-day, but it is a really good phone for testing and for looking at how well 6 gigahertz works. It's the S22 Plus is what that is. So what we're going to do is try to use this phone to connect to our 6 gigahertz AP and be able to test a few features such as throughput, what channels can it see, can it even see the SSID, that kind of thing. The other tools that I have, I like to, for frame analysis and looking at other Wi-Fi parameters, I like to use the EtherScope NXG. This is the NXG 300. It has a 6 gigahertz radio, allows me to do some frame captures over the air. And what I'll do is use that to show you guys how we can view the 6 gigahertz channels, all the different settings within that AP. Because from my initial testing, I have seen different things from APs. It's not always the same configuration. But Chris, thank you for checking in from Nigeria. Wow, that's quite the ways from California here. But thank you for joining in. I hope you're having a great day out there. Now, what else do I have in my lab? I do have more access points besides the EnGenius access points, but we're not going to be plugging those in. One of those access points is a Juniper AP45. This is also a tri-band AP, very capable, cloud managed. Was testing this out yesterday, trying to figure some 6 gigahertz stuff around EduRoam, SSID, and also SSID we broadcast on our campus. Now the other another AP that I will be testing out in the future, something I need to get more familiar with, is the RUCKUS AP. This one is much larger. It is the RUCKUS R760, tri-band as well. It's got LEDs here at the top, a lot more LEDs than what you see from some other access points. But looking forward to testing that one out in the very near future. So I think that's everything I have. Oh, one other tool that I like using is or that I started using, is the what is it called? The WLAN Pi. I have the M4. Finally got that thing up and running, and it could actually be a tool that you leave behind in some environment, and you could actually attach it to Wi-Fi Explorer. So I'll show you that as well. Jean, thank you for checking in from Canada. Yeah. Thank you for listening to the podcast as well. So if you don't know, I run the Clear Descent podcast with Francois, who is from Canada and Ontario. So check out cleardescent.net. We talk about Wi-Fi there all the time. So why don't I just start kind of diving into what we've got here, right? So what we're going to be looking at is, I gotta log in. I was just in there. It kicked me out. So this is the login dashboard for the EnGenius cloud. So I'm not going to be running any on-premises controllers. We may do that in the future with Cisco, but we're going to be focusing on the EnGenius cloud. They talk about AI driven here on the left, if you can see that. I haven't tested AI stuff with EnGenius, but their cloud architecture is very it's actual cloud. It's like a native cloud architecture where they've got different microservices. So it's pretty cool. There is some free. It's mostly free, but they've got some pro features that would require some licenses. So let me log in here. Give me a second. And with the EnGenius AP, it is very easy to add it to the cloud. All you really need is an IP address for your access point. And then in the back of this access point, there is a serial number here, or or a QR code that you could scan, and you could actually use an application on your mobile device to onboard the access point into your dashboard. So you can see this here is where I'm logged in. You can manage a lot more than APs. You can also manage switches and gateways, which we can get into much more in the future. This is the main dashboard where I am looking at my test net. Okay, so there's a hierarchical design to the dashboard, and we're looking at my recording studio, which is just my room here. So there's a dashboard. You can view all your access points. I have only one access point. You can see that, I don't know why it only shows 149 and channel 5. That's new to me, but we'll take a look. Okay. There is a configure section at the top left. I'll go to access point and we'll just take a look at SSID. All right. So I've already set up a couple SSIDs here, but we'll kind of go through these settings because I already did the onboarding piece. And what I didn't want to do is kind of show you all the stuff I shouldn't be showing you when onboarding, because I don't want you to onboard my AP to your cloud. And Adrian, thanks for chiming in as you prepare breakfast. I don't mind at all. It's a kid-friendly channel. It's funny because last night we had friends come over, so I really didn't get to bed until about 1:30. So my kids are still fast asleep. So let's see. They won't be bothering me anytime soon while I'm doing this live stream. But so I've got so keep in mind, I got my AP onboarded already. I'm not going to go through that. What I'm going to go through are some parameters for configuring the EnGenius 6 gigahertz AP. So what I did was I probably should have described it. On the top right here, there it says add SSID. It might be cut off a bit, I think, but on the screen, but there's an add SSID on the right, and you will have a lot of options here to go through. Pretty in depth for a small business access point. I think it's very capable. Now the name section is where we're going to write our SSID name, right? So we can call this StreamNet, for example, and I have it enabled here in the next section. Now there are two types of SSIDs. There's just a standard wireless SSID and something called SmartCast. Now I haven't played with SmartCast, and it does require a pro license with a specific firmware version, but we're not going to play with that today. And we're not going to hide the SSID because you cannot hide an SSID in 6 gigahertz. It's got to be either WPA3 or it's got to be OWE. Now, down here onto radio, something to take note of. I have a blog post on reduced neighbor reports. There are other blogs on reduced neighbor reports and 6 gigahertz discovery. This is an important thing to note, that if you disable 2.4 and 5 gigahertz, it is possible that your devices are not going to find the SSID. They're not going to be able to discover your 6 gigahertz SSID, because it appears that devices have decided, or device manufacturers have decided, that you need to have that SSID, the same SSID name, also enabled on the other bands. And that's how a device will discover a 6 gigahertz SSID. So if I were to show you Wireshark right now, so we'll skip a little bit. Skip. I'll use Adrian's tool. Adrian is from Intuitive Bits. I hope I said that right, Adrian. He developed this tool to help discover 6 gigahertz SSIDs using a WLAN PI. Or if you've got the new Mac that supports 6 gigahertz, you can also do it that way as well. Hopefully it works in my lab. I need to make sure I have my network settings all set up here. I am on the network. Okay, so I will not use the WLAN PI. I forgot to get my IP address. All right. So when we're configuring the SSID, we want to at least enable 5 gigahertz. All right, so I'm going to disable 2.4 gigahertz for now. And then as we go down to the security types, this is where it gets interesting for 6 gigahertz and 5 gigahertz, because for one, device support is probably limited when it comes to OWE, especially with the older, what we'll call legacy devices. And that's going to this open security type. And open security type is used in 2.4 and 5 gigahertz. It's just an open SSID. There's no authentication. There's no passphrase that we're using. It changes when we go to 6 gigahertz, where 6 gigahertz, instead of open, it's going to be OWE, or opportunistic wireless encryption. And what that does is your traffic over the air will actually be encrypted between the access point and your device. I won't go into all the little details about OWE, but just note that when you enable an open SSID in 6 gigahertz, it has to be OWE. And so the one thing that I want to test here, we won't do it on this live stream, but what if you have an OpenSSID on all 3 bands and a device goes between open and OWE? Like what is that functionality? What is the experience of that device? And the same goes for a pre-shared key. When we move to 6 gigahertz, we're no longer dealing with the older security types. We're not going to deal with WPA2 at all. We're going to deal with WPA3. Now you can configure WPA3 for 2.4 and 5 gigahertz, but so you can see here in EnGenius, it's actually showing you that the this security type, WPA3 personal SAE, simultaneous authentication of equals, all these acronyms. You can see that it's supported under 2.4, 5, and 6 gigahertz. But again, do all devices support WPA3? Now you also have this WPA3 personal and WPA2 mixed. What that means is it will use WPA3 transition mode, and it will use WPA2 in 2.4 and 5, or for devices that support it. But if you have a 6 gigahertz capable device, it will use WPA3, and especially if it's using it in 6 gigahertz. And then you've got WPA3 Enterprise, which you'll need a radius server. I'll maybe do something about that, do a lab on that in the future. But for now, we're going to keep it very simple. We're going to use a WPA3 personal with a passphrase, and we're just going to call this testing 1, 2, 3, 4. All right, keep it simple for the lab purposes. As we move down further, you can see I can't even enable 802.11r for this network, or 802.11w is going to be required in 6 gigahertz. And then we can tag the VLAN ID for this SSID. So I'll go ahead and do that. If you don't have one set, you can use the default VLAN, which is the native VLAN. So whatever the network the AP is on, that's where it's going to drop your devices on. I already have a VLAN called VLAN 11. Just for lab purposes, I pre-configured some of this stuff yesterday in a rush. So we'll select VLAN 11. If not, you can actually go in here and just configure one. And so we're going to bridge the clients to that network. Now, I don't use these other features, dynamic client VLAN pooling, enable application analysis. I think that adds additional work for the AP. But if we scroll down, there are advanced settings, things like layer 2 isolation, MDNS forwarding. There's band steering that I cannot select, and this suppression of broadcasts and multicast. There's other configuration items. Well, I guess before I move on, does anyone have any questions? Anything they want to say about the configuration of this AP? I have it on right now. It's connected, and yeah, I may be a little concerned about how it looks. Were you guys able to see the configuration I made on the screen? Trying to get it to focus. There's an LED, so you can see 6 gigahertz was actually enabled. All right. Let me know if there were any issues going through that. I can go through it again. Let's see here. We can keep going. All right. So there are configurations that we can go through, other ones that we can go through on this SSID, like bandwidth limit. Something I would never recommend doing to an SSID because we're already dealing with things in half duplex mode. Why complicate it even further? Then we've got captive portal, so you can see how extensive this is with all the different authentication types of a captive portal. Again, something else I would never want to configure on an SSID. We've got a splash page, something else I would never configure on an SSID. You can schedule when this SSID is enabled or disabled. So according to whatever schedule you set here, you can set the time that it is available to use or unavailable. And then we've got access control, which is a very simple policy. You can mark devices as a VIP, things like that. So once you're done configuring this SSID, on the right, it's cut off a little bit. You just click on apply. So once you click on apply, it will send the configuration of this SSID down to the access point, which we'll be able to see in a few minutes, maybe even less than that. So Jean, thanks for your response there. Now's a good time to take a sip of coffee, right? Because I've been talking like crazy. Is there anything you guys want to see specific with the access point, the Wi-Fi 6E configuration? Go ahead and let me know. All right, so I do want to note that I have my SSID already configured, right? You can see it's really odd that here, last updated 2 minutes ago, it doesn't even list 6 gigahertz channel. Or is this channel 5 is what it is? Yeah. Okay. So what I was getting confused about is I don't like it when it just lists the channel numbers, because now that we have a lot of 6 gigahertz channels available, some of the channels will look like a 5 gigahertz channel. And I think having a little icon saying 5 gigahertz, 6 gigahertz would be useful. So what we can do is look at my SSID that I configured. I'm going to primarily be using this testnet SSID. If you want to see the configuration, this is it. It's the same thing, but we'll go to the dashboard. We can see that it's online, right? There's usage, and we can also see clients down in the dashboard as well. So these are all the different devices I've connected. It doesn't give you like in the last hour or so. It's more like the last day, and you could organize it by or filter it by SSID. What I like using more is going to access points and then looking at details. So we can view the details of the access point here, where here's where it shows channel for 5 gigahertz and channel for 6 gigahertz, and also the transmit power. So there's you can tell I'm using a 160 megahertz wide channel right here. This is where it's showing it right there. Now it also shows you all the SSIDs that are broadcasting from this access point. So 3 SSIDs going, but I only have 1 client on one access point, and you can see it's on the 6 gigahertz spectrum. And you can look at throughput, and then also manually configure the channels, right? So I have it set to auto at the moment for 6 gigahertz and also 5 gigahertz. All right, so let's talk about how I would analyze the 6 gigahertz. But before I do that, does anyone have any questions? Is there any option to configure 6 gigahertz AP to OWE? Jean, yes, there is. Sorry, there's a delay with the live stream. So yeah, there is a option to configure that. I'm not going to do it in this lab. It's just going to be, that would just make it an open SSID. But as long as your device supports OWE, it'll be able to connect. So I think for the future, when we implement this in the general public, it'll be interesting to see how many devices actually support OWE, and do they have a problem connecting. All right. So earlier I had talked about the WLAN Pi. What I want to do is kind of bring up what a WLAN Pi is if you haven't heard about it. And it's this neat little tool from a group of great guys who have this project that they're working on as a tool for Wi-Fi professionals, or even just for someone who wants to be able to analyze Wi-Fi a little bit more. Now, there are different types of WLAN pies. I have this one over here on the right, and it's actually plugged in to my it's in my little lab rack in the closet, and I have it plugged directly into the switch. And so I'm able to access this WLAN pie over the network and then add it into Wi-Fi Explorer. It has a Wi-Fi 6E chip in it, so I can then use it to view, scan the environment for 6 gigahertz networks. All right, so I have this WLAN pie. You can learn more over at WLANpie.com, which is right up here. You can make a purchase. You can purchase them from different places. All right, so if we think about scanning, right? Because what we're John, thanks for joining. If you want to know what hardware I'm using in the lab, right now in the configuration, I'm using an EnGenius ECW336. This is a tri-band access point. I do have other access points here in my lab. I have a RUCKUS R760 that I'll be testing out very soon. That's also a tri-band. And then I also have a MIST AP45. So this is the MIST AP45 that I'll be testing. I have 2 of these, so I'll be able to test roaming and a little bit more extensive testing rather than just using one access point. All right, so what I want to do is head over to Wi-Fi Explorer because I finally got things connected there. So this is Wi-Fi Explorer. It's by Adrian. He was in the chat earlier, and he may still be listening. So if you have questions for him, you can ask that in the chat. But Wi-Fi Explorer is on the Mac. It's gonna be coming to Windows soon, as well. But you can see here I am scanning on my M4, which is my WLAN pie, and it has a 6 gigahertz antenna on it. Now, my MacBook that I'm streaming from does not have 6 gigahertz on it. I don't have the new MacBook yet. So from my MacBook, I cannot do a scan to even see if there is 6 gigahertz SSIDs out there. Now, the way I added this is right here. I added it as a remote sensor. So that's the M4, and that is the IP address of the remote sensor. I'm on the same network. I think I have a 10.10.11.18 IP address. And so I added it here, and now you can see I'm filtering everything to 6 gigahertz. Now, these are the 3 SSIDs that I have configured. One is from the MIST access point, an AP45 that I have plugged in my closet. It's sitting right on top of the switch, and the WLAN pie is right next to it. And that's why you can see that the WLAN pie hears that SSID at -34. Now, the interesting part is I'm not too far from my lab. It's roughly about, I don't know, 10, 15 feet away from me. It's just right over there. I have a door, just a standard door in my house, and you can see that from this SSID, which is this EnGenius that's sitting right on my desk. This is the access point broadcasting testnet and testing SSID. You can see that WLAN pie that's in the closet is hearing that 6 gigahertz SSID at -84. All right. Some of the other things that's interesting is the MIST test AP on channel 165. It has 9% channel utilization. I'm not even sure how that's possible, unless we've got some 6 gigahertz clients. Now, the cool thing about using the WLAN pie is you don't have, if you don't want to, or you don't have the funds to spend on something like a EtherScope or an AirCheck G3 with 6 gigahertz capability, the WLAN Pi is a more affordable option, and you could use your laptop, or you can just get a new MacBook Pro with 6 gigahertz, right? But because of this, we can now see a lot more details, right? We can go and click on advanced details, be able to see some capabilities of this access point. So the EnGenius here is 4 spatial streams, right? And we can go in here. You can see the RSN information element. You can see the auth key management list, AKM list, and you can see it's SAE. So again, that's required, right? There's even this new one, hash to element. I haven't looked at that before, but now we can see what you would typically find in a Wireshark capture, right? So there's the transmit power report, and then you can compare that to something like, say, this MIST AP. Now we're at a utilization of 3%. It is broadcasting its BSS load. The EnGenius doesn't do that. This is also 4 spatial streams, and here is a neighbor report. So I like using Wi-Fi Explorer as much as possible. It's very easy to use, and you get a lot of information out of this because now we can look at, say, the spectrum. If you've got a spectrum analyzer, you can attach that to the M4, the WLAN M4, and be able to actually pull in some spectrum here as well. All right, so before I move on to the next tool and further testing, let me know if you have any questions. I'll answer it. Again, the stream is slightly delayed, so when I see the chat, it's not exactly super quick for me. So what I'm going to do now is go over to Link Live. And now Link Live is what I'm going to use to look at my AirCheck G3. I want to remote to it, maybe do some captures. So I'm going to get that staged up real quick. And I still have my phone here. It's at 100%, so we are good with that. So while it's loading, oh, that was fast actually. So this is the EtherScope I have here, right? I actually have an AirCheck G3 as well that is plugged in near my my lab unit, and it's connected via Wi-Fi, so I can connect to it remotely using Link Live. And so if we look at here, this is Link Live. This is the remote connection I've made to to my AirCheck G3. Now, what I want to do is go to Wi-Fi. It's going to open up the channels map. Let me see what settings I have set up for it real quick, because I don't think I preset it. Right now, it is scanning only on the 6 gigahertz band. Very specific. I was probably doing some testing, but we'll enable 5 gigahertz and 6 gigahertz because there's something that I want to look at. Okay, so I'll go back now. And now here you can see on the top left, it's going to scan through all the channels. It's going to note here how many APs it has detected on those channels, and then it will also display how much 802.11 traffic, non-802.11 retry rates. That's why I love this tool. I use it for a lot of analysis. So we're looking at 5 gigahertz here. Now it's going to start scanning 6 gigahertz, and it can detect an AP on channel 5 and channel 165. Right. So if we go to, let's go to SSIDs. I'm going to filter it on a very specific SSID, the testnet one that we had configured. There it is, testnet. All right, so we'll filter on that SSID. You can see it says here's a testnet at negative 47 dBm. I will tap into that, and here we've got, it says 2 APs, right? One at negative 47 Do I have testnet running on another AP? I'll look at this negative 63 dBm. Right, so these are the SSIDs it can detect off of this access point. That's the one sitting right here next to me. It shows it at negative 62 dBm, WPA3 personal, and these are the two SSIDs and the channels that it sees it on, right? All right, so if what I'm looking for is why it doesn't show me the 5 gigahertz. It's saying 5E. Well, anyhow, if we look at SSIDs, we'll look at testnet. So these are how you can view the parameters of a Wi-Fi network that's a type, protocol types supported, BSSIDs. You can see the channels. Oh, now there's 2 channels. Okay. So there's channel 149. You can see the utilization, channel 5E. What I like to do is capture on this channel, right? So we can see things like RF and traffic statistics. So if you were troubleshooting the Wi-Fi network, and here we can scroll down and see things other than signal. We can see utilization, retry rate, and those are the things I like to look at. Now, what I want to do is just kind of simulate some traffic here. Let me do that real quick. So I'm gonna try to push some traffic over the air to this access point that's right next to me. You can see utilization going up. This is one single device, my Samsung S22 here. And you can see retry rates very low. Okay, that's great. What if you wanted to do further analysis, right? We wanted to do like a capture, a frame capture. Now, it's interesting to know like how efficient you can be with frame captures. You may not be able to capture everything, especially when it comes to the multi-user aspect of Wi-Fi or OFDMA. So we may not be able to see all of the traffic from all devices. And I don't have multiple 6 gigahertz devices to run all these tests. But what we can do here, I'll go to the capture settings because it defaulted to a 20 megahertz channel width. Now I do know that I have a 160 megahertz wide channel. So I want to capture on that whole channel, right? File size limit there if you want to limit how much you're capturing. And what I'm going to do is try to capture the association. Okay, so we'll start this off. We'll tap on start. It's now capturing. I turned on the radio. The phone is connecting, and you can see some traffic there, right? Now the AP is connected. Maybe I'll trigger some other traffic as well. And there we go. So now I'll stop. When you stop this, you could save this up to link live. And so this is how I'm going to use my tools to kind of analyze 6 gigahertz. This is how I come up with some of the blog posts that I write and some of the stuff we publish on Clear to Send. This is the analysis portion. So I'm just going to say live stream as a comment so I know where to look. All right. So this will go ahead and upload it using the Wi-Fi management radio of the AirCheck G3. And it has another radio for testing the Wi-Fi, right? So that is fairly quick look at AirCheck G3. Let me know if you have any comments there with the AirCheck. And so while hopefully that's fully uploaded, I'm going to go ahead and download that file so we can look at that in a very short time. Because what I want to do is talk about like throughput, some other things around, I guess, capabilities. And so what I'm going to show you because what is an example? What does everybody want to get out of 6 gigahertz, right? In this lab, I have the AP sitting right next to me. It's right here, right? I have a VMware server, a virtual machine, configured with LibreSpeed. Okay, it's an open source speed test server. We actually have that on the WLAN Pi as well. I can show you that. But what we want to do is see, what kind of bandwidth or throughput are we getting out of 6 gigahertz? Is it what we would expect? Is this equipment too early? Does the drivers and software need more development when it comes to 6 gigahertz? So those are the kind of things that simple tests that I want to look at, right? So I've got a speed test server set up. I got LibreSpeed here, and all we're gonna do is we're connected via 6E. You have to make sure on the top right, we can make sure of that here. If we go to, let's see, let's go to clients. All right, seen 3 minutes ago on testnet. This is my client right here. So if I click on that, here you can see it connected not too long ago to testnet on 6 gigahertz channel 5. So we let me remove this picture in picture. It's interesting that you get a timeline. This is how EnGenius saw my client, my device, what IP address it has, what SSID and what channel it last associated to. So on the timeline down here, you can see at the timestamp it joined to this SSID, and on the right side we've got the band and also the channel and its signal strength. So even though I'm right next to the AP, I'm connecting at negative 49 dBm. All right, guys. So now I pull up the VM at LibreSpeed, right? That server, that VM is on a Supermicro server. It's got a 10 gig Ethernet port connecting to a RUCKUS ICX 7150 switch on its 10 gig port. It is, I have confirmed that is on 10 gig. And then what I want to do is try to get, say, over a gig in the speed test, right? So I'll tap start. What do you guys think this is going to get, right? Maybe put it in the chat. What speed do you think we're going to get out of this speed test, being that I'm sitting right next to the AP, the device is sitting right next to the AP. Put in the chat what you think we're going to have. So here we go. I'm starting it. AP's right here, okay? That's the speed. So right now, getting 439 down. Let's see the upload. Peak in there, 1.3. That's pretty good, right? As far as upload goes. The download, kind of questionable. So I ran into this yesterday. Now I think it might be something with the channel. It's definitely not the server, because I'm hardwired in, and if I did a speed test to that same server, I would actually get a gig speed with my laptop. Now, there's some things that I need to look at and analyze, like what did I do wrong with the configuration? Is it because Samsung doesn't like 160 megahertz wide? I don't know. And so I need to test it with other access points as well. Now, well, one thing I do want to show you, I have another VM. Okay, so maybe it's LibreSpeed. I don't know. It could be the browser. And what I'm really talking about is that limiting download speed. It should be a lot higher. Now I do have iPerf installed as well. And so that's one thing that I wanted to test. So if I show you, I'm going to bring up iPerf here. And it's the same server. I'm going to do it, do about 20 seconds iPerf test. I'm using iPerf 3. This is going to be more of a download scenario, and I'm going to have it show me every interval, every second, what the bandwidth is. All right, so if we look at that iPerf 3, Jason, thanks for subscribing. Appreciate it. So look at that iPerf test there, right? This is download. So take a good look at that. Look at the bandwidth column there on the right side. So those are very different numbers than what we were seeing with like Libre tests, right? Now I know they're different testing tools, different testing methods. One's more browser based, and it's actually pushing and downloading and uploading a lot of data there. Where iPerf, it's, I did a very simple iPerf 3 test, but the bandwidth I got every interval was over 1 gig, right? Now the results can change depending on how close you are to the access point, what your SNR is, how good the frequency is. There's a lot to it that affects the actual bandwidth on 6 gigahertz. So for example, if I move this access point behind me, or even under me, under the desk, we can probably see a huge difference. All right, so I move the access point. We'll refresh this iPerf 3 test. Look at those speeds. All I did was move it under the desk. All right. We were over 1 gig, and now it started off at 500 megabits, hovering around 900. So there's a huge difference there. And the point I'm trying to make is you've got to practically be right underneath the access point in order to get really good speeds. German, thanks for joining. I would hope you would prioritize your wife for dinner instead of me, but I appreciate you joining. Mark, local speed test with a 2.5 gig adapter. You get full speeds. Yeah. So there's something going on there with the download speeds, and it's kind of comforting that you're having the same types of issues as I am, because I don't know what's going on right now. Jason, if it's mounted above, so I have, if you can't see, I have a that tripod there where I can mount my access point. I was going to do that for this live stream, right? So the EnGenius APs come with a bracket. There's a reason why it's not mounted there. This is the bracket. Now it goes, let me just grab the AP for you. Now it slides right in here, okay? And then you could mount this to a T-bar. The problem I have, or the problem I ran into when I did it, is you can see this is the bracket. I don't know if you can tell what's wrong there. And this is what's wrong. This piece broke off. So it doesn't fully clip. So I had full intentions of mounting it properly. I was going to put it right above my head here. I think my ceiling height is about 7 feet. So I was going to put it up there. And I don't have a whole, I have a drywall, but I don't have anything up there to make it easy for me to change the AP out easily. And then the other problem I have, this RUCKUS AP, that doesn't fit on there. It's way too wide. So I have full intentions of mounting things properly, but for simplicity's sake of this lab, I just have it here, sitting here. And just to show you, like, even though this phone is directly above the AP, I don't get the results that I was expecting. And now I tested it with another AP, and I got the same kind of results. So why don't we go look at link live real quick because I just want to show you what that looks like when it comes to analyzing things from a frame level. And the reason why I use the air check or the EtherScope to do frame captures, and why you may want to use an AP, another AP, to do frame captures. So this is link live here on the left at the top here. The link AirCheck G3 uploaded my PCAP file to link live. It did the capture for me. Very simple. So I'm just gonna export it, download it to my laptop, and then we can take a look at what it looks like from the EnGenius AP, and then you can even do comparisons with other APs with the feature sets that are enabled. And so I'm opening Wireshark right now. So you can see it's fairly empty in 6 gigahertz. Here's the beacon frame. If you want to see some of the information, you got a radio tap header. You can see the signal, data rate. What I really want to get to, it's a lot of stuff. This is when my phone started associating. So you can see probe request, probe response, probe request, probe response. Authentication, we're getting acknowledgments. So I'm seeing what I want to see here, right? This is how I like to do some deep analysis of 6 gigahertz to see what are we getting out of our 6 gigahertz APs, and what data rates are we getting, for example, right? So here you can see I'm using the APs using the lower data rates to send some of the management beacon frames. But if we look down here, I've got data frame. Look at that data rate. So this here is my phone sending to the AP. No. I think that's my phone. No. See, I should have noted which one was my phone, but you can see the data rate, 1,297. Now I'm trying to find some higher data rates. Here's one at 1,441. So this is how I do the packet captures. And yesterday, late evening, I was trying to look at the data rates during the speed test. Now I think I still have that file available. Here it is. Let me open it. And let me check real quick on comments. So, John, Ubiquiti AP, yeah, I can test that. I'll get my hands on one. Gotcha. Overload, yeah. So I've tested it in a variety of different ways. I have it set in my lab. I have it set over there. It's the same speeds. Once it goes into my lab, it's about -70, -68 signal strength. So what I plan to do is test attenuation of 6 gigahertz and roaming between 6 gigahertz and 5 gigahertz because of signal strength. You need an insane SNR for like the higher data rates in order to get the better speeds. So just for the lab, I'm only testing it here on my desk just so it's easy to reach. But earlier yesterday, I had it placed over there on the table. And then I have a MIST AP in the lab as well. That's we can do a test with the MIST AP if we have time. What I want to do is look at the Wireshark capture I took yesterday. Here we go. Like, look at these data rates here. So these are pretty good, right? And this, I think, is mostly the upload. So if I look at my phone, let me go to settings. Where do I find the Mac? I'm not an Android guy. So when I go through this phone, I don't know where things are. So the MAC address, Oh, I changed it to the phone MAC. So 8940 is the last four. Randomized MAC. 4378. So 4378. This is my phone transmitting to the AP at that data rate. So getting pretty good data rates, I think. If we look at the MCS chart, we'll be able to see what that is, right? So 1729.4, right? 1729. Can you find that in here? I don't even see that data right here. This is the MCS chart for OFDMA. I have my Samsung is a 2x2, so 2 spatial stream, 2x2x2. Somewhere doesn't even show it. That's interesting. Maybe I'll go to the full table. Do a search, 1729. There it is, 1729.4. MCS 8. No, that's not right. It's not even a 4 spatial stream. Oh, here it is up here. So I was connecting on OFDM. It's probably because I have just one device. So what I really need to do is add another device, get some spatial, get OFDMA running. But it's just some initial testing. I did have my AP set up for it's using its RRM. So if I showed it to you, the access point, the access point is set up for RRM. I can select the channels. Some APs are a little bit smarter where you can tell it to use the preferred scanning channels. But you can select a preferred scanning channel if you want. So the thing with 6 gigahertz that I think we'll see is maybe 80 megahertz might be the default channel width. 160, I think you won't have enough channels in a lot of environments. And what's going to happen is you'll have OBSS, and that will cause some issues. Mark, you've got the Ubiquiti 6E, seeing similar results. Okay. It'd be interesting to see what others have. I'll put up my results for the APs that I'm testing. Also, I wanted to test out devices, so I'm trying to get a hold of the MacBook Pro 6 gigahertz. Won't quite get the iPad. I don't think. I don't even have a good use for an iPad. It's kind of sitting here right now, uncharged. I was trying to use it for this lab. But I don't know. What do you guys think about 6E? Do you have 6E APs in your lab? Are you going to test multiple APs? I think that's where the real test is going to be, is having multiple access points and being able to see how devices roam between APs or even between bands. My concern is getting a client connected initially on 6 gigahertz, but as they move around the area, they'll probably reassociate at 5 gigahertz. And so I wanted to test things out, like roaming between bands and also between security types. And this is where just going straight to WPA3 instead of having some sort of transition mode will be beneficial, I think. So I'm getting ready to, I started initial planning of 6 gigahertz testing and interoperability with devices roaming. So hopefully I'll have something to publish or set as a presentation for Prague, a WLPC Prague, or next year's WLPC Phoenix. So lots to consider with 6 gigahertz. I don't. Now that Apple's putting it in their products, we're probably going to see it become more mainstream. Will we see things with mesh? I'm not sure how well that's going to work out. I don't have any intentions on testing that because I don't think mesh is very good. But Mark, you're roaming between Ubiquiti. and using Bentoners and Oversight. Yeah, I just downloaded an Oversight, so I'm gonna need to get familiar with that. I guess that's where the iPad Pro will be useful, right? But you can also use it on the Mac. I would more likely lean towards the MacBook Pro than an iPad. All these tools get very expensive, so I don't have Apple giving me products to test out, but it'd be cool to see what that looks like, and then maybe we could have a place to compare a lot of these different scenarios. So Mark, I think you and I will be talking quite often. If you guys aren't already, we have a Slack channel for Clear to Send, and so I set up an EDU channel because that's where I'm mostly wanting to learn more about how we should implement 6 gigahertz and what that looks like. And so with the campus that I'm on, I'm going to be picking certain environments to test that. Now I have the 2 MIST AP45s here in my lab, so I will be setting up a teleworker and then moving one AP to another room, keeping one here, and trying to see how that roaming is going to work between SSIDs such as EduRoam. So that's my lab, my 6 gigahertz lab. Looks like a lot of you are starting to build your own. I don't usually play that much with Ubiquiti. I tend to use a lot more of the Cisco APs, MIST APs, RUCKUS, but interested to see how Ubiquiti is handling 6 gigahertz and what kind of capabilities we have for some debugging or even getting logs out of how the device is connecting. How does the AP see the device, vice versa. So hopefully be able to use the WLAN Pi a little bit more extensively as a client. One thing I didn't test was maybe a speed test between my phone through the AP to the WLAN Pi, because the WLAN Pi has a speed test server too. So let me punch that in on this phone, 10.10.11.19. All right, so this is the speed test server for the WLAN Pi. And so this is where things will get interesting, all right? I'm gonna start it. You can see now it's gonna do the download. Look how much better that is on the download, right? So is it something with the APs? Something with my VMware VM server? That's what I was trying to troubleshoot yesterday. So something along the path is not quite right. Upload. This time upload is not as good as the download. I believe the WLAN Pi that I'm using is only a 1 gig Ethernet port. So it's not going to get over a gig. But that's much better, right? Pretty cool. I want to thank you guys for joining me on this live stream. I haven't done one in about 2 years, but I want to try to get into it again. I have access to a lot of different equipment, so I have the ability to do testing. Once I get my server, my 10 gig server running properly, maybe we can do more throughput tests. Maybe I'll set up one that'll just constantly stream video. We can do some video tests over Wi-Fi. Try to put some load on these access points, right? So as more devices come out, we'll be able to do more testing in my lab here. I got to get more tripods, more Wi-Fi stands to fit the larger access points. It's just how it's going to be, right? The access points are going to get bigger. We're talking about 2x2. This is the size of a 2x2. The R760 is pretty large, so access points will just get larger because we've got more radios. We'll see 4x4s, 8x8s. Dare I say 16x16? I don't know. But if you guys found this pretty interesting, go ahead and let me know in the more of the comments. It's more mostly appreciated. Anything you guys want me to test out and compare with your tests, or something you want to be able to see what's happening on 6 gigahertz, let me know. And you can subscribe and get notified for when I go live the next time. So my next lab that I want to work on is actually getting the RUCKUS R760 up connected to a smart zone controller, and then configure that 4.6 gigahertz and do the same kind of tests. So I'm trying to create a structured test that I can replicate across access points just to see if there's any difference between them. Are they mostly the same? Does it matter if an AP is worth $2,300 versus one that is $300, $400, $500, sub 1,000? So I think it'd be interesting to see what we come out with, even if it's just very simple tests, right? I find that these APs should exceed expectations on a single device testing, right? That's just my opinion. But once we add more APs or more devices, we'll see how they react to under stress and under some load. But I want to thank you guys for joining me here on this live stream. Greatly appreciate you taking the time out of your Saturday. Saturday is what works for me on a live stream, just because at this time my kids are still sleeping. But Ubiquiti 6E, all right. That's another request for 6E. Mark has one, so we can compare notes, and we'll go from there, guys. Thank you so much, and I hope to see you on the next live stream. And Mark, looking forward to seeing what you've got going on with that AP4000 in the lab. Like, so guys, if you haven't heard about WLPC, go ahead and Google that. That is the best wireless conference to attend. Lots of incredibly smart people. You learn about Wi-Fi, and if you join late on this live stream, it's fine. It's going to be recorded, so you can go back and see a lot of good comments here. So if there are a lot more tools. One tool I haven't mentioned that I was using is the N Oversight by Ben Toner. It's a good tool for iOS and Mac OS devices to get. You can generate a sys diagnose log and be able to analyze how your device is interacting with Wi-Fi. But yeah, Jason's lab. Jason, thanks for joining. I think I've seen your channel, so I appreciate you supporting me here on this channel. And I'm open to any comments you guys want, and any tests you guys want to see. But thanks again. I'll let you guys know on the download issue what I find. Maybe I have a feeling it has something to do with my VM server. I think it has something to do with that and the browser. Because I did test over wired. It's weird. Yeah. It's definitely weird. But thanks again, guys. Greatly appreciate it. I will see you on the next live stream. Bye, guys.